Hello, Math Analysis, and welcome to your Chapter 4, Lesson 6 notes. We are going to rationalize multi-term denominators this time. So basically binomials, not going to get too much crazier than that. This brings us back to when we were talking about multiplying in the second lesson, so lesson 4, and I started multiplying conjugate pairs together. And you noticed that when I multiplied conjugate pairs together, the middle radicals canceled each other out. The deal with that is, right, that it leaves us a whole number, and that whole number is allowed to be in a denominator, while radicals are never allowed to be left in a denominator. So now, if we have more than one thing in a denominator that is a radical, we need to multiply the top and bottom by its conjugate. Now, there's some of those pieces we're going to be able to do on our graphing calculator, which is great. So it'll save us a little bit of stuff we have to do in our heads. Okay. But, and a little bit of foiling, especially. But for the most part, we're going to have to write out a little bit of work for these. Okay. So that's why I saved the best for last in the chapter. This is the last thing we do with expressions. The final thing we do is solve equations. Okay. So here is my example, my classic example, always present. Never leave a radical in a denominator. I look at this and notice that there are two terms in the denominator. And what I need to do to get rid of this now, because there's a radical term and a number, I can't just multiply by radical 6. Because if I do, and I multiply 2 by radical 6, I'll still have a radical in a denominator and won't have solved any of my problem. Okay? Because my problem is the fact that I have a radical in a denominator in the first place, and it's not allowed to be there. So what I have to do instead is to multiply top and bottom by the conjugate of 2 plus radical 6. And the conjugate of 2 plus radical 6 is 2 minus radical 6. And when I multiply these two things together, so let me just show you that that is something I'm allowed to multiply together in my graphing calculator. So when I multiply 2 plus radical 6 times 2 minus radical 6. Darn it. I over-radicalized. Let me try that again. Arrow out first. Then, there we go. 2 minus radical 6. There we go. Over-radicalized. So there we go. There's the conjugates. And can I even press that? Nope, it's not going to let me because that bar is in the way. There we go. Press enter. There we go. A whole number remains. So as long as we've got that whole number remaining there, now we're good. There's no more radical in the denominator. So that's what I put there. But the thing is, if I do something to the denominator, if I multiply the denominator by something, I also have to multiply the numerator by that something. Okay? And you'll notice that when I did that here, I cannot just type that into my graphing calculator. That's not something that I can type in. Okay. At least I can type in the conjugate pairs. So there we go. So then I distribute. So this is radical 11 times 2. So 2 radical 11 and radical 11 times negative radical 6. And that's negative radical 66. I then look here and I say, oh, no one's evenly divisible by a perfect square. Nothing can simplify further. So I have to literally bring these down to the next line. Then I'm just going to look at my coefficients. So 2, -1, and -2. None of those are evenly divisible by the same thing. They can't simplify any further. That's it. That's my final answer. And there's going to be a lot of, wow, that's a little messy, but that's my final answer. That's the best I can do. Okay, so there's going to be a lot of that. So just kind of be prepared. So here we go. Let's get it started. I look here and I've got two terms in, opposite direction I wanted to go there. Let's zoom in instead. I have two terms in my denominator, which means I have to multiply top and bottom by the conjugate of 3 minus radical 7. And what's the conjugate? It is 3 plus radical 7. So if you see two terms in the denominator, It's the conjugate of that you multiply top and bottom by. So the bottom is nice and easy because they're conjugates. I can just type them into my graphing calculator. And actually what I'm going to do, this is kind of a nice hint, is I'm going to press 2-second and enter. And that gives me the last thing that I typed into my graphing calculator. Okay. Then what I'm going to do is just arrow backwards and change my radical to have a 7 in it and change my number to be a 3. Then I'm going to do it again. Radical is going to have a 7 in it, and my number is going to have a 3. And that is my conjugate pairs that I have multiplied together here. So I press enter. Oh, it's just a 2. Okay, cool. That means in my denominator, there's really just a 2. Do I have to write out all that work that I just did in my graphing calculator? No, I do not. On the top, I distribute. 1 times 3 is 3. 1 times radical 7 is radical 7. So 3 plus radical 7 is what I bring down for my numerator. Let's look at all the coefficients, see if there's anything we can reduce. 3 and 1 and 2 are my coefficients. They are not all evenly divisible by anything. So I am done. There's my final answer. 3 plus radical 7 divided by 2. It's going to be very common to see something like that. Okay. So now 2 terms in this denominator. Okay. What is the conjugate of 3 plus radical 3? Hey, 3 minus radical 3. I heard you. I know. You said it loud enough. So I multiply top and bottom by 3 minus radical 3. Okay? So I can type that conjugate pair into my graphing calculator, and that is what I do. I'm just going to second enter. And this time, because 3 is already the number, I just have to change the number in the radical to match. Isn't that nice? Kind of makes things a little easier. Okay, now I can press enter, see what my denominator is going to be. 6. Sweet. My numerator, I distribute. So 3 times 3 is 9. And 3 times negative radical 3 is negative 3 radical 3. Now I look at all my coefficients to see if they are all evenly divisible by something. And this time they are. 9 and negative 3 and 6 are all evenly divisible by 3, right? So 9 divided by 3 is 3. Negative 3 divided by 3 is negative 1. And the radical 3, of course, comes with. And then in the denominator, 6 divided by 3 is 2. There is our final answer. So if the coefficients can all evenly divide by something, then we do it. All right. Now, so far, you'll notice that our numerators so far have been single terms. That, of course, does not necessarily stay the case. So I will do these 2 up here just because I want to do as many examples as possible, but I just want you to see we're heading towards having multiple terms in our numerator as well. Okay. Here we go. All right. C. Yes. And C. Okay. What is the conjugate of 4 minus radical 6? 4 plus radical 6. Good job. Top and bottom get multiplied by 4 plus radical 6. Okay, let's figure out that denominator via graphing calculator. Via, what language is that? Good old Latin. Guys, you benefit so much from the fact that I took Latin in high school. I'm telling you. Miss Melton, my Latin teacher, would be so proud. Keep going. Here we go. Okay. So I'm multiplying these conjugates together. This is going to be my denominator. It's 10. Sweet. Now the numerator, I'm just distributing. So 2 times 4 is 8. And 2 times radical 6 is plus 2 radical 6. Nothing to simplify radical-wise, but those those coefficients are all even numbers. So 8, 2, and 10 are all evenly divisible by 2. What is 8 divided by 2? 4. 2 divided by 2 is 1. You don't have to put the 1 in front of the radical 6. It can just be radical 6. And then, of course, 5 divided by 2, or excuse me, 10 divided by 2 is 5 for the bottom. I was jumping ahead. I was jumping ahead mentally. There we go. That's it. That's our final answer. Remember, these cannot add any further. One's a rational number, one's an irrational number. They're different number sets. They can't combine any further. That's the best we can do with those two different types of numbers. If they had the same radical attached, if they were both radical 6s, then we could add their coefficients together, but they're not. So we can't. Ooh, here's another one. Now we got a radical in the numerator. Well, we're fine. Why does that still say intermediate algebra 2? Old. Conjugate. There's 2 terms in the denominator, so conjugate is 6 plus radical 2. So let's multiply top and bottom by 6 plus radical 2. Now let's type those guys into our graphing calculator, because why make life harder than it is? So let's arrow over. We got 2, we're going to change that radical to, and 6 that we're going to change that front whole number to, 2 that we're going to change our radical to, oops, went too far, 6 that we're going to change that front whole number to. And see, that's our conjugate pair multiplied together. And we get 34. 34 is our denominator. Okay. In the numerator, let's distribute. 6 times radical 3 is 6 radical 3. And radical 3 times radical 2 is plus radical 6. Now, here's the deal. Let's look at these two radicals and see if I can simplify them. Is 3 evenly divisible by any perfect squares? No. How about 6? Is 6 evenly divisible by any perfect squares? We cannot simplify those, and they have different radicands, so we cannot add those further. Those are 2 completely unlike terms that cannot be combined any further. That's the best we can do. Now, the other problem, quote unquote, here is the coefficient in front of radical 6 is a 1. So 1, 6, and 34 do not have a common divisibility. So we're done here. That's it. And actually, you know, in a way, kind of easy, because we're done. Nothing more we can do. It's the best we could simplify that. But it's rational now because there's not a radical in a denominator. So now that it's rational, we're good to go. Okay, let's look at these ones that have 2 terms in the numerator as well as denominator. All right, so just a little bit different. Same deal. It's exactly the same deal. It just might look a little bit like more work. And by saying that it looks like more work, it is. We still look to the denominator. We still multiply top and bottom by the conjugate of the denominator. So 3 minus radical 5 is what we are going to multiply the top and the bottom by. So I see what's happening in the top here. I can see it. All right, let's plug that into our graphing calculator. Again, why make life harder than it is? And let's just change the radical to a 5. And let's just change the front number to a 3. So we can get that conjugate going here. It's nice to have that option, right? So, okay, 4 is my denominator now. So we've rationalized the denominator. Cool. Now we got to FOIL the numerator. 3 times 3 is 9. 3 times negative radical 5 is negative 3 radical 5. And we got a FOIL, so now it's negative radical 5 times 3 is negative 3 radical 5. And then last, right, is negative radical 5 times negative radical 5, which is positive radical 25. But remember, that was radical 5 squared. So the square root of 25 is 5. You could have just simplified by saying that the radical part canceled out. 9 plus 5, so I'm going to simplify a little further here. 9 plus 5 is 14. Negative radical 5, negative 3 radical 5, plus negative 3 radical 5. See how they're like radicands? I can actually add their coefficients, so I get negative 6 radical 5. And then, of course, my denominator was already simplified. It was a 4. And now I see that they're all even numbers, right, in the triangle of coefficients. 14 is even, 6 is even, 4 is even. So let's divide them all by 2. 14 divided by 2 is 7. Negative 6 divided by 2 is negative 3. And the radical 5, of course, comes with. And in the denominator, 4 divided by 2 is 2. There is my final simplified answer. Does take a little bit longer to do these, but it's not that bad. Let's do B. The conjugate of 6 minus radical 6 is 6 plus radical 6. Okay. Let's multiply top and bottom by 6 plus radical 6. I'm going to use a little bit of this just so I don't take up too much space down here. The more you press second and enter, you can go back a few entries. So I'm going to press second and enter until I get right here. See that? So that way I just have to change the radical, not the number in front. Nice little cool thing about the graphing calculator. So there we go. There are the conjugates that I'm trying to multiply together. Press enter to see. They give me 30. Okay, now let's double distribute or FOIL on the top. 3 times 6 is 18. 3 times radical 6 is plus 3 radical 6. Radical 6 times 6 is plus 6 radical 6. And radical 6 times radical 6, well, okay, I'm going to write it out again, but remember, I could just lose the radical here. But what that really is positive radical 36. And what is the square root of 36? It's the number 6. So that I could have just eliminated the radical on radical 6 times radical 6. The radicals canceled out when we were squaring. So now I can add the numbers up, and I can add the like terms in the middle because they have the same radicand. So 18 plus 6 is 24. And 3 plus 6 is 9 radical 6s. And of course, this has all been over 30 the whole time. That's my denominator. And I do notice that my coefficients are all evenly divisible by 3. So 24 divided by 3 is 8. And 9 divided by 3 is 3 radical 6s left here. And 30 divided by 3 is 10. And that is the best I can do. But that is nice and simplified. No radicals in denominators, guys. Never, ever, ever can you have a radical left in a denominator. Ouch. Just cut myself on my desk. Last example. Then you're trying it on your own, but you can do this. I'm just going to say, I feel like I just had that denominator, and I did. Look at that. I can go up a little ways. Okay. The conjugate, let's do it in red because I have one a little too close for comfort right there. The conjugate of 4 minus radical 6 is 4 plus radical 6. So let's multiply top and bottom by that. All right, so let me figure out my denominator first. So I'm just going to press second and enter a few times to go back to where I had that 4 plus radical 6 and 4 minus radical 6. There it is. Right, because I already had that as denominators. I already had that as conjugates, so I could go back long enough to, I'm shedding, to get that one back. And what did I have? 10. Cool. Suppose I could have just looked up, but showing you how the graphing calculator works. Oh boy, we're going to distribute on the top, and this is going to get messy. Let's FOIL. 2 times 4 is 8. 2 times radical 6 is plus 2 radical 6. Radical 5 times 4 is plus 4 radical 5. And radical 5 times radical 6 is plus radical 30. Oh my gosh. Guys, look at those. Can't Can't reduce, not divisible by any perfect squares. Can't reduce, not divisible by any perfect squares. Can't reduce, not divisible by any perfect squares. Nope, 30 isn't. Not the same, not the same, not the same. So now maybe I have coefficients, right? Except even, that's a 1. Nothing here can simplify further. This has to be left all separate. That's it. That's your answer. Very rarely, but sometimes that's going to be the case. Okay, very rarely, but it can happen. Okay, so we have to remember how to find our conjugates. So remember that conjugate pairs have an opposite sign on the inside, and when they multiply together, when conjugate pairs multiply together, the middle radical term cancels out. All right, I'm going to answer the phone, but good luck, guys. Let me know if you need anything. Bye.